I'm Joyce Hornady. You might say accuracy is my business. I make bullets.
You are listening to the Hornady Podcast.
Thanks for joining us and enjoy the show.
Hello, everybody. This is the Hornady Podcast. I'm your host, Seth. Thank you for tuning in to this episode, and we've got an episode set up for you homeschool ballistic guys, the advanced hobbyist. We've got our ballistic panel set up here, and ultimately, I think the name of this episode is going to be Uncomfortable Ballistic Realities. And while this won't be a specific individual episode about an individual topic, we're going to cover several topics that are going to dispel some myth and some dogma, which really the whole podcast we've been trying to do. The whole Hornady Podcast since the first technical one we ever did. That's really what we've been trying to do. And so to help us do that, to my left, senior ballistician Jayden Quinlan. Across the table, project engineer Miles Neville, who in him we trust. And then author and ballistician Jeff Siewert. Guys, thanks for coming on the show.
Thanks again for having me.
Now, I'm not going to spend too much time talking before we dive right into here because we've got a lot of ground to cover. A couple things. Number one, for the listener, you probably want to watch this one. Jeff, as always, brought in some excellent presentation to help us understand these complex topics. And number two, if you aren't into ballistics and science, this is probably not a good episode for you. But if you are, this is going to be a good one. And number three, so far at this table, Jeff's the only author of a book. And we've had a lot of requests for, where's Jayden's book? When's Jayden's book coming out? I promise you, you look in our YouTube comments, I have seen a lot of them. People want you to write a book about ballistics.
Really?
Yeah, oh, yeah.
Do they know he doesn't know how to read?
It would be real short. Yeah, I don't know how to read neither.
Yeah.
Not no good.
Now, most people won't know this, but you are a published author. I've seen your work years ago.
Many moons ago. Yeah.
Outdoor and hunting magazines and such. Miles, you can read and write. You should have a book as well. You can co-author.
I'll do the pictures with my left hand drawn.
Okay. No. You'll use Microsoft Paint like you used to.
It would be too
Excel.
professional. It wouldn't be an adequate representation of my capabilities.
Oh, gosh. All right. Well, before this devolves, we're going to dive right into some uncomfortable and maybe mind-altering, as Jeff put it, ballistic testing realities. And the first one, we don't have a slide for, Jeff. I'm going to read this first one that you outlined. And for the listener, these 12 things that we're going to walk through, Jeff put these together. And the first one, I've fallen victim to, and I'm going to read it here. Rule number 1, it doesn't matter how knowledgeable or experienced you are. If you reload enough, sooner or later, you're going to do something boneheaded. Period.
Yep.
That's a reality.
And that's on the spectrum. I mean, you can go from, so what, that's a little bit inconvenient to bad, catastrophic.
Mm-hmm.
Inconvenient is I loaded the bullets too short. Now I got to go pull them all and resize the necks and put them back in. That's inconvenient. Or another one that I've done way too frequently of late is I resize the cases and the distance between the base of the case and the shoulder datum is too long.
Oh, they don't go back in?
Oh, kind of avoids the point of resizing. Hold the bullet, though.
Well, yeah, especially with the belted cartridge cases.
Oh, sure.
That's you're going to run into that. On the catastrophic end, you can pick the wrong powder.
Oh yeah.
There's a guy that I'm familiar with. Actually helped him get started in reloading, and he managed to pick the wrong powder. Gun came apart, and he's got some vision troubles at the moment.
Wow, well. Hopefully, he makes a.
It's not as catastrophic as it might have been, but you got to be careful.
In my technical days, working on answering the phone, we had a gentleman call in, mistaked H1000 for H110 in his 338 Lapua. Oh. So you can imagine what 90 grains H110 does to a Savage 110. It's
not pretty.
It wasn't pretty. It does
everything.
Yeah. And I would second that. Been reloading most of my life. Started as a little fathead with Dad, to present day, one of the most notorious Seth faults in reloading is I used to have a steel trap memory, and I don't anymore. And, I'll load 20 of these for this hunt or this whatever, and I'll know that it's got, 40 grains of Varget in there with the 178 ELD X. Nope, don't remember that. And I'll find ammo where I didn't take proper notes. And at that point, pull the bullets and powder goes into the garden outside, and I'm starting over. And just taking simple notes about what you loaded when you put it away in your gun cabinet can go a long way as well.
We had a colorful euphemism about that when I was working with the gun guys, and they called it instantaneous disassembly.
You don't want
you want to avoid that at
Definitely.
all costs. So take that with all of the weight that it means. That it doesn't matter how long you've been doing this, Jeff. You've been doing this for decades.
Yeah. So my first big problem happened after 25 years of reloading. I picked the wrong charge weight. Got the right powder, but I picked the wrong charge weight for a monolithic copper bullet, and then the load data was for a cup and core bullet, and opened the breech on a Ruger number 1, and the primer was missing. I tore the gun apart. It's amazing how many parts there are in a Ruger number 1. It's kind of shocking, but I didn't find any primer parts in the mechanism. So I have no idea what happened to it. The next one was I was reloading a 300 Ultra Mag, and I did two boneheaded things with that particular batch of ammo. One was I managed to load a cartridge case that didn't have a primer in it.
Dang it. Inconvenient.
Very inconvenient. And the other one I managed to load a cartridge with no powder in it.
Equally inconvenient.
And that also feeds into one of the later slides, so we'll talk about that.
Yeah, well, let's, moving forward, everybody out there, the listener, us included at the table, I got Jayden one time with a cartridge with no powder in it. It's 280 Ackley we were shooting out with for radar.
Yep.
We were shooting the 198 tips for drag.
Bang, bang, poof.
Yep.
Yeah, thanks a lot.
Yeah, got you good. Moving on to number 2 here. The primer output might not generate enough pressure to move the bullet. Now, what's that mean, Jeff?
Well, in that 300 Ultra Mag, I loaded a cartridge with no powder in it, and I loaded the cartridge into the gun, pulled the trigger. I heard the snap, but no kaboom.
Mm-hmm.
And the cartridge volume is big enough on that cartridge case that it didn't move the bullet at all.
Sure, there was enough space for that pressure to dissipate.
Yeah. And, one of the things that was done way back in the mid-'80s, when the Germans did a dictated transfer to the U.S. on 120 millimeter tank ammunition, one of the things that they did was they came up with some inert simulants of propellant and put those in the cartridge case and compared the output of the igniter only. And so, when the American performance was equivalent to what the Germans had, we were good. We moved on.
Mm-hmm.
So, but I think that's like what happened with your 280 Ackley Improve with no powder. Did that bullet move?
No. What happened was Jayden really slowly opened the bolt and turned his head very slowly like Chuck Norris and stared me down. And he set the round down and we moved on. But I could see, is it possible?
If you had a much smaller cartridge case, you could pop the bullet out into the rifling. Now you've got things locked up.
Yep.
Yeah, I've done that with 5.56, like 223. I've done it, and I don't know if it was. I just ran out of powder in my thrower, but I did it in 30-06, so I don't know if there may have been like a partial charge in there as well. But it didn't make it. I could tap it out with a cleaning rod, so it couldn't have been much.
Yeah.
Yep, just enough to push it out.
Hopefully, it does not leave the case, because that creates a really dangerous situation where if the bullet is able to make it into the free bore and the forcing cone, or maybe a little bit into the rifling, and you don't realize it, and you stick another one behind it, that can be catastrophic.
Yeah, that's what saved me with my 30-06 was that it was stuck close enough that the next one wouldn't chamber.
Yeah.
I ejected, empty case came out, and like, oh, that was weird. Like, didn't click right away that that's what had happened.
Mm-hmm.
So previously, I've related the story about the 155 stickers.
Yes.
And basically that was we did it intentionally.
Mm-hmm.
Did a binary search, cut the charge, wait till the bullet doesn't exit the tube. And the interesting thing there was the fact that in cutting the charge, the pressure drops and then it drops. And then suddenly it goes back up with a further reduction in powder.
Mm-hmm.
Like, what's going on there? So what goes on there is the bullet makes the jump into the rifling, stops, and then the volume generation is considerably lower than it would be normally. And the powder burns, and then the bullet exits after the bullet has come to a stop and then resumed travel.
And that come to a stop, getting it restarted is where you see that pressure spike.
That's right.
Yep. And a lot of that's important to remember. I think we've talked about it before, but especially when you're new to reloading or hand loading and you're super conservative, you're worried about everything, right? So you're like, I want to use a really low end, like I don't want to be near those red numbers in the book at all, You can go too far the other direction and become dangerous too. So pick something that's in the middle of what's published or on the lower half or whatever it is, but don't think that continuing to go down makes it only more safe. There's a point of diminishing return there.
Absolutely. Yeah, the first time I saw that, I think I've related this on the podcast as well. 243 Winchester, small case, small bore volume, 4831, very slow propellant. You can run 4831 with great results, and if you go too far down, you could definitely generate this. So yeah, 1 and 2 here, kind of related. We're moving on now to number 3. This one, I'm going to read it slowly so that I can understand it. Make sure everybody unpacks this question, or this statement rather. The powder with the slowest relative quickness might not have the lowest muzzle velocity change or per powder weight change. Did I read that right?
So that's
this graph
chart
right
here.
Yeah.
So what I did was I was trying to understand the whole interaction between the projectile and the propellants, and why powders with lower relative quickness had more sensitivity to changes in powder weight. Like, how does that
doesn't make sense?
Doesn't make any sense at all. And it's back to the sticker problem. So if your powder, you can see here, so generally speaking, we've got most of the powders are faster relative quickness in red, but there are a few slower relative quickness than the optimum. The optimum for me is the one that has the lowest change in muzzle velocity for a change in powder weight.
Yep, that would make sense.
Okay, so that means if you're loading that propellant into that cartridge, you have the least sensitivity to a small change. Let's just say you're trickling and I went over by a tenth. Is it important? You can decide that for yourself. But if you pick this powder for this application, then you're going to have the least sensitivity to changes in powder weight. And so, okay, great. Is it universal that you've picked the lowest relative quickness powder? And the answer is no. So there are some other powders that have lower relative quickness that have more sensitivity. And I think the reason for that is back to that sticker problem, where the bullet makes the jump from the cartridge case into the rifling, and you haven't generated enough pressure for things to keep moving.
Mm-hmm.
So the bullet slows down, the relative rate of change of volume behind the bullet slows down, and that causes the pressure to spike up higher than it would normally.
That's interesting to look at your graph there and see, or your table rather, that the tubular and the ball propellants, there's an example of each where one is more sensitive than the other.
So you can't make any generalizations.
So you can't make a generalization on ball powder or stick powder.
Right. Now, I haven't done this for the whole reloading manual, but I mean, just something that folks should have a look at.
Yep. Something to be considered, especially if you're throwing them out of a powder measure. All right. Number 4, this one, buzzword. There are no velocity nodes.
What?
End the podcast. Yep. No velocity nodes. Let's investigate this one. There are no velocity nodes. Now, before you answer, not to be confused with accuracy nodes, which we'll talk about here in a minute. But this one, just related to velocity. There are no velocity nodes.
Yeah, the velocity nodes are the result of low sample size test.
I can't believe, Jeff, there's a velocity node right there. You can see it on the screen.
Look at that.
It's got a
and here's
green
my data.
circle of
Are you saying my groups are too small?
I'm done talking.
Yeah, so here's my data, and this is
fire data.
Yep.
Oh, okay.
Yep. Along with reloading manual data in the black dash line on the low end. So the firing data was from a barrel that was a little bit longer than you would normally have for a 300 Win Mag.
Yeah.
And it was my nephew's rifle, and so we got a little bit higher velocity average than the reloading manual, and 50 feet per second for 3/4 of an inch. That's in the realm of reasonable.
Yeah, that's some of that.
Yeah.
Maybe different throat, different.
Well, yeah, barrel to barrel, you'll see
right
up to 150. I mean, depending on who makes the barrel.
And so my approach here was to say, okay, does the slope reasonably agree with the reloading data?
Sure does.
And if it does, and my data says that I'm above the line and I don't have a longer barrel, that means I got to creep up on max charge much more cautiously.
Sure. Yeah, that's interesting, and I've heard there's people that do their load development specifically on velocity nodes, where they're looking for air quote consistent velocity based off of usually 2 or 3/10 of a grain increments, and they're looking for where the velocities line up.
And so what the fly in the ointment there is the fact that there's a minimum of about somewhere between 5 and 10% change in resistance pressure as the bullet gets engraved in the tube. And when that happens, that's one of the biggest, that might be the biggest driver in changes in pressure and velocity. Mm-hmm. So you're going to get those randomly when you do a ladder test like this, and the flat spots are really meaningless.
Yeah. I've got multiple data sets. I don't even know how many now, of basically the same thing, doing powder ladders with different powders with 6.5 Creedmoor and 6 Arc, and they all show exactly the same. But I'll do like 25 or 20 or 35 shots at each charge weight as you go, and you can map out all the little 5-shot group ladders that are just...
Oh, I've seen that. It's a busy graph when you put it all together, but you can see like, if you shot these 5 in a row, it would look like there's this magical flat spot.
Right. Yeah, but they never repeat. When you do 7 of those on top of each other, it's just a mess of crisscross lines. Mm. And then when you put them all together, it's almost basically linear. It's not always perfectly linear, but pretty much a linear trend of more powder, more velocity, just a smooth increase if you run the averages out. All
right, you heard it here for the 100th time. Your groups are too small. Velocity nodes don't exist. That's definitely one of those uncomfortable truths or uncomfortable realities in ballistics. Number 5 here. All cartridges leak gas or powder by the bullet early in the interior ballistic cycle. So you're saying that during the firing event, there's gas that's outrunning the bullet during that initial acceleration.
Yeah, and that happens kind of, just thinking about it, just a little thought experiment. The shallower the forcing cone angle, the farther the bullet has to travel before it seals the bore, right?
Yep.
So the sharper the angle, the less that is, right? So most medium cal guns have about a 3-degree forcing cone angle.
Yep.
And in the book, there are photographs of sabot projectiles, and those are important because the stuff flows by the cartridge case and condenses on it, and you go pick up the sabot pedal pieces, and every one of them's got some gas residue on it.
Mm-hmm.
So this is some screenshots of some folks on YouTube that have taken some high speed videos, and there's always a precursor flow that exits before the bullet comes out.
Sure.
Always.
And there's no way that got there if it didn't escape around the bullet.
It had to.
Yep.
It had to.
Makes total sense. That's pretty cool to see the unburnt propellant coming out of there.
Yeah, that's
typical.
and not good. Like, because all of those little things have mass, and some of them are going to go tink, 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 tink all over that, and probably not in a uniform way. So having unburnt propellant doesn't necessarily help you in any way.
It's almost always there, though. I mean, to some degree or not. That's quite a bit. But
I would say that you're more likely to get that with ball propellant, because that stuff, I mean, all of the other dirty little secret is almost all powders are blends. Yeah, like it or not. You know, there's a fast blend stock, there's slow blend stock. I mean, they blend them to give you the right performance that you're after. There's probably a bigger spectrum in terms of web size with ball powder than there is with extruded powder. So, I mean, if you had to, that might be one of the reasons why folks choose extruded powders for their accuracy loads.
Yeah, and that's completely anecdotal in my experience, and we've echoed that here, that if I was looking for accuracy, I'm going extruded single-based every time.
Yeah, do they burn out? I mean, the simulations that I've made say that the extruded powders tend to burn out.
Yeah, might be more investigation needed for you guys.
Yeah.
All right, number 6 here. This one, I dare not even read it, but I'm going to. Accuracy, aka dispersion nodes, they might exist.
Oh,
they
thank
do
goodness.
exist. But you can't take advantage of them.
Blasphemy.
Let's hear about this. So you're saying dispersion nodes do exist. However, they exist in a way that you can't manipulate them to affect the dispersion.
Yeah.
Okay, let's hear more about this.
Okay. So I've previously presented this for you guys. These are the blue lines here, the blue dots are all the angular rate. That's the wobble of the bullet. Okay. And the orange is the cross velocity. And you can see there are some regions in which the wobble is minimized. It's pretty low. Okay. The problem is, the 0 here is the average performance, and the plus and minus 1, 2, and 3 standard deviations, those come along for the ride. You can't avoid them. Okay? So here, this response is, I would call it bifurcated. You've got a bunch of them with very low angular rates, and then there's this population where it's very high. Like, okay. And so, try as you might to keep the pressure and velocity in a low change range, you can't do it. You just can't avoid it. So if you're sampling, you might put 3 shots into one of these things.
You might coincidentally get the 3 lowest.
Precisely. And the next time you go shoot them, you're going to get a different result.
And that's the important part. If it's real, it will repeat. So if you find something that you think is incredibly good or exactly what you're looking for, aligns with your biases perfectly, do it a couple times. Does it do it every time? If it doesn't, you can't trust it.
Yep. And here's another way of looking at it. If you find something that doesn't meet your criteria or your expectations, does it not meet your expectations every time?
Right.
Is it really bad? To Miles' point years ago when we first kind of discussed this topic, oh, that didn't meet my expectations or my thoughts of what it should do. Well, I'm not going to retest that because it already failed. That would be another way to acid check. Is it real or not? Because a lot of times, you get into that, what do you call it? The confirmation funnel bias.
Yeah, confirmation bias funnel.
Yep. And you exclude all of those things that already failed. But if you would have just tested those again, you would have probably found that they perform differently every time. All right. So accuracy nodes, they may exist. However, there's nothing you can do to manipulate that node to improve your dispersion.
True.
All you can do is shoot a large enough sample size to get a good idea of your cone of fire.
Of what it actually does.
Yeah. To put it another way, and to throw back to like the dispersion podcast we did and stuff, if you could find the source of the angular rate and the cross velocity, whatever that may be, in board tilt, center of gravity offset, whatever it is, if you could find the source of that and then clock it so that it was the same every time, you could make yourself a node.
But you can't do that.
You can't do that.
Yeah. Frustrating.
Well, you can if you drill a hole in the side of the bullet to make things way, way worse, and then you clock that hole in the same position.
Yeah.
But your ability to clock it exactly in the same position isn't so good. So although they're way worse over here, they're a little bit better way over here because you clocked them, but you still can't.
Maybe we need
Can't do it. We need square bullets and
we need
square
polygonal,
barrels.
cross-section bullets so we can clock them.
It's getting out of line.
We'll get right on that.
Yeah. All right. So moving on
Well, I would say, just to go back to this too, we see this kind of behavior as well, just in like, I don't know how you'd say that. Just looking at a shot group of a ton of shots, 20, 30, 50 shots in a group, and we look at it. When you look at a different array of different components put together, barrels, bullets, powder, whatever, you'll see some of them that, like super tightly cluster 80% of them, and then 20% are just kind of randomly out there, out of that cluster. And then sometimes you get the same total spread that's an even distribution, and sometimes you get like rings around the outside or slanted bias or different things. And it's, I assume, just some combination of all of the components coming together. But as you do more and more and more of them, then you catch more and more of the spread. And so I guess, I don't know, a 3-inch group at whatever distance, is not just a 3-inch group. They all kind of have like their own unique little thing to them. But yeah, it's just the combination of whatever is going on between your forcing function and your barrel and whatever.
Yeah, that's the jump plot. Do you have the jump plot in this one? The jump diagram.
I do not have that.
Okay.
Yeah,
I think we've covered that before.
So basically, you're telling us that the fixture doesn't do its part.
And it doesn't really matter because I've shot
the fixture's the fixture. The fixture doesn't change. It's just a random thing, and it happens.
Right.
All right. Now we're moving on to number 7. Nearly all bullets wobble when they come out of the barrel, but it doesn't mean that they're unstable.
So here's a video of the bullet wobbling in flight.
Mm-hmm.
This is a visual of angular rate.
A visualization of the angular rate of the bullet as it comes out the tube. And you'll see that wobble gets smaller and smaller and smaller.
If things are good.
Yeah.
If things are bad, it can go the other way.
I would like to, we'll discuss this a little bit further, and then I have like a additional question, or I'm going to pose it as a question because we'd get this a lot back in the day, and I'm sure our tech staff still gets this question. So here, in a perfectly stable environment, walk us through why that wobble doesn't mean it's unstable and why that wobble gets smaller.
Okay. The stability of the bullet, there's 2 factors. We've talked about that quite a bit. The first part is the gyroscopic stability. That's, do you have enough spin? Obviously, this bullet has enough spin. The other part is the dynamic stability. Does the
more complex?
There's a lot to the dynamic stability equation, and you can't just make a few numbers. You have to continually check that as the bullet goes down range, and the only way to actually do it is to run a 6-degree of freedom trajectory simulation. You got to
have some horsepower.
You got to have the computer take care of that, because you can make some numbers, and the thing you won't have lined up correctly is the spin to velocity ratio.
Okay.
And you can compute that if you just reduce the velocity with the given twist barrel, but you won't have it as it actually exists in flight.
Okay.
Because we always lose velocity faster than we lose spin.
Got it.
Okay. So let's see. Does that answer?
That
doesn't answer
quite.
the question.
Okay. So we did a whole podcast on stability. We focused almost exclusively on gyroscopic stability, and we just summarized dynamic stability as if the angular rate is progressively either staying the same or getting slightly smaller as the bullet continues downrange.
The magnitude of the off, as long as that's getting smaller, the bullet's dynamically stable.
All right, that's what basically I was after. Now, my question that I had as a follow-up to this was, years ago, you'd answer the phone in tech and you'd get somebody on the phone. Notoriously, they were 338 Lapua shooters. That they have this huge 338 cal bullet, 285 ELD match, 300 grain match king, whatever they're shooting, and they were under the impression that they would be able to shoot smaller groups at longer range because the bullet had gone to sleep and that it was dynamically stable the further out it went, and so it might shoot 2 MOA at 200 yards, but by 400 yards, the bullet's gone to sleep, and now they're shooting 4-inch groups at 400.
So, the groups always, if you did fly through targets, the groups would always get larger as you increase the range.
Mm-hmm.
For the bullet groups to be smaller as a function of range, what would have to happen is an all-seeing, all-knowing entity would have to be watching your bullet and push on it exactly at the right place at exactly the right time.
This is exactly the answer I was looking for.
with exactly the right amount of force,
mm-hmm.
and guide the bullet back towards the center.
Yeah.
I believe in God, but he's got better things to do than babysit my bullets.
Yep.
That's right.
Yep. And I'm guessing largely this was small sample size. You get
you shot 2 different groups.
Right.
Yep.
Yeah, every
Right.
single claim I've seen of that is not the same group caught in 2 different ranges.
Right.
It's always, I shot this group at 100, it sucked. I shot this group at 300, it's awesome. What's going on in between there? Well, it's like if you shot that group that was good or bad at 100 at 300, it would have been equally as bad, if not worse.
Yeah.
So,
Yep. You just got to shoot some more.
It can happen at longer range, but it is such a small possibility.
Yeah,
so essentially
velocity
what could happen is, right,
it's-
so you, like at closer range, you're pretty much just getting a snapshot of the raw dispersion, right? The exit state of the bullet out of the barrel is causing it to go in this direction, to the right, to the left, high, low, and populate the middle, right? So you have a group at 100 or 200 yards before velocity variation can kick in and affect it, drag variation affect it, all that stuff. So let's just take the highs and the lows. We went over this in the hit probability podcast. The highest shot at 200 could have the slowest velocity of the group. And as it continues downrange, that slower muzzle velocity causes it to move back towards the center. But to envision that, you have to, because you're talking about up, down, left, right. So all of those would have to coincidentally be the right, to your point, a divine intervention of applying the right force at the right time in the right amount. It's not going to happen. Like if it happened, it would be like a 1 in a gazillion.
And you
which
can
is
never trust
gazillion's a real number too. So don't question it.
Gazillion is 60 zeros.
And we've done some testing with this here, this topic recently, where we've got shot markers at 100 and then again at 1,000 yards or whatever. And then we get the radar along board, with it. And what you'll see is that after you shoot, basically, as you step the range out, 100, 200, 300, 400, it's almost pretty much entirely linear. The horizontal component is so great compared to the vertical component that your muzzle velocity variation doesn't have time to show up. Your drag variability doesn't have time to show up as a vertical spread. It's there, but it's so small that it's imperceptible. You're still producing basically round groups. The dispersion is pretty much almost exactly linear. It starts to decay a little bit by 400 or 500 yards. By 500-600 yards, you get a little bit of dispersion decay. And then from like 600 to 1,000, it's like time and a half, 2 times the dispersion. The cone just opens up. And then you get all the components of that vertical stuff, all the components of the drag variability on wind and everything, and wind variability and gusts and whatnot. But then even when you back all that out, all the vertical component back out, it's like it gets worse.
Yeah, unless you do your part.
Right.
And even then.
Yeah.
All right.
Concealed carry, personal protection or home defense, only the best will do. Critical Defense Ammunition, developed to provide the best performance for personal protection, no matter what platform you choose. Delivering consistent, reliable performance every single time. When lives are on the line, only the best will do. Hornady Critical Defense Ammunition.
Moving on now to another really topical one, especially in the world of 338, because man, the 338 ARC is out there, and boy, did that kick over a hornet's nest. It seems like this one related here, but also in the world of precision rifle as well. Number 8 reads, more stable bullets, meaning a faster twist rate, doesn't mean smaller groups. Said what I said.
This whole podcast is full of blasphemy.
Yeah. So faster twist rate does not mean
you very
smaller
much.
groups. Now,
Your title
Not
couldn't
to
be
be-
better, Jeff.
not to be confused with like the minimum twist. You need a certain amount of twist rate, obviously, for gyroscopic
Yeah.
stability. But once you obtain good gyroscopic stability, is there any benefit to going with a faster twist outside of terminal performance?
I don't know. I'm sure you've got something to say, but yeah, like I've seen basically an SG of about 1.2 to 1.25.
The stability factor.
Right.
Yep.
Once your gyro stability is about there, dispersion is not a factor. Go below that, dispersion becomes a factor in a hurry. And then I don't really, there's like the drag benefit up to.
Yeah, certain bullets will show a benefit in drag, lower drag, maybe lower drag variability. But that's generally like when you get to the super long, heavy aerodynamic bullets for that class or that caliber. But you take a super fast twist rate barrel, you might see a benefit versus something that's producing a gyro of 1.2 to 1.5 or whatever. But you put a different bullet in there, something that's not as long, L over D's less, aerodynamics are different, and that difference that you see in performance completely goes away.
Yeah.
And I think the point that Jeff's going to make is that even though you might have a benefit drag perspective, which everybody would want, right? That's going to help your long distance performance. It's not for free. There's this other trade-off that happens, which I think, Jeff, is what you were going to discuss.
See some complex equations. I was just doing these equations last night before bed just for fun, but they're pretty elementary.
Put you to sleep.
Yeah, right. Let's have a look at these, Jeff.
Yeah, so from let's just use the term design practice perspective in medium cal, large cal. You want the bullet to be gyrostable at launch at ambient conditions, of course, but you also want it to be gyrostable at cold temperatures.
Mm-hmm.
And the design practice was, let's get an SG of about 1.4 at ambient, and that way when we take it to cold temperatures, as long as we're not firing in an aircraft, we'll be good. Okay. So on the left-hand side, we have the gyroscopic stability equation. What's in there is the polar moment of inertia squared. That's the resistance to acceleration or deceleration. Okay. So that's square. That term is squared in the numerator along with the spin squared. Okay. And in the denominator is a bunch of other stuff, most notably the pitching moment coefficient derivative. Now, you've talked a little bit about the lever arm trying to dump this guy over. That's the distance between the projectile center of gravity, center of mass, and the normal force center of pressure. And that distance in calibers multiplied by the normal force coefficient derivative is the pitching moment coefficient derivative.
Of course.
Well, it's just the way things are.
Right.
So you can see that this guy is in the denominator of the equation, and it's also in the denominator of the jump equation.
The aerodynamic jump.
The aerodynamic jump equation. Mm-hmm. And so the faster you spin the bullet, let's make that guy go up. What else goes up is the angular rate.
So the bullet wobble is going to wobble harder. super simple
Yeah.
way to look
Right.
at it.
Yep.
Right,
I had a flat
exactly.
tire in the Amigo the other day. This exact thing happened.
Did it?
Yeah, I felt, wonder what that is. And then I shifted into fourth gear and went a little faster and was like, oh, I know exactly what that
You
is.
upped the twist rate on your Angular 8
Yeah.
tire and you felt it, is what
and
you're
the
saying.
wobbled harder.
Huh.
So
You might have to take me for a test drive.
So let's bring a little bit of test data into this.
Okay.
Okay. And this is all normalized so that it's not sensitive. Okay. It's what I did was I took the performance with the 1 in 12 twist and made that 1.0.
Okay. So this is a 30 caliber, 30-06, 308, 1 in 12.
Something like that.
Mm-hmm.
Okay. 1 in 12 twist, 1 in 10 twist, and way over there is a 1 in 8 twist. And so this is the expected dispersion and the plus and minus 1 standard deviation.
Okay.
Okay. With normal, we would call it standard landing groove geometry. Okay. And so when we increase the twist rate, we got a little bit of a reduction in dispersion. So that's a bit of a head scratcher. Like, okay. And as we decreased it, they've made the twist even faster. Now the dispersion started to uptick. And if the CG offset times the spin rate and the inbore angle times the spin rate, those are the two factors that drive the group size. They should follow this black line. But they don't.
Yeah.
So that was, for me, that was a bit of an epiphany. So that means that something else is driving the bus when it comes to the dispersion at small dispersion levels. Okay. Different land geometry, there's a bias smaller at the same twist rate. And as we go up in twist rate, we didn't get the same sort of increase in dispersion we would have expected.
Interesting.
So this is in the book.
Yeah.
And it was, now I do have to caution folks that this is for one particular bullet.
Sure. Yep. But as a generality, two things to take away from this as a generality. Once you get a properly stable bullet, there's really no huge benefit to going with a faster twist. It's not going to help the dispersion, and it may cause some other problems.
And for this particular bullet, there happened to be a benefit with the faster twists in terms of downrange performance, in the subsonic range. But that was that particular bullet shape. And that along with better repeatability, barrel to barrel to barrel. And again, that's for one bullet shape. What's going to happen to your bullet shape? You have to do the test.
Yep. Good to know. So another takeaway from this, related but not the point of this talking point though, is that in that slide previous where you had the gyroscopic stability formula, we've talked about this a bunch in our gyroscopic stability podcast, but there were two things in there specifically that is individual to a specific projectile shape and mass layout. So if you're using a Miller stability formula that has what I'm going to call standard bullet shape in there, those numbers aren't specific to your bullet, and you're not going to get a very reliable SG number.
Right. If you read my book, you'll learn pretty quickly I'm not a fan of that particular metric for stability.
Yep. So that's what's out there available to most. You just Google bullet stability calculator. Yeah, it's probably going to run it through that stability formula. And while it's better than the Green Hill, it's nothing as good as an actual mass layout of your projectile.
Absolutely.
Which you can do using
Absolutely.
FortOff. And for the listener out there, Jeff, you mentioned it. You got to read the book. I'm still getting texts and emails currently like, I just got my copy. I just read it for the second time, et cetera, et cetera. So you're making good headway in getting the advanced hobbyist, the non-Bubba, getting them spun up with that awesome piece of work.
I knew it kind of hit the big time when people told me last year that I was being given as a Christmas gift. So,
all right. What a gift.
Good point on that. You touched on it, but in FORDOFF, if you're using the actual 4 degree of freedom solver in our app, if you pull a bullet out of the library, that is actually using a full math physical model of the bullet to generate all the stability numbers. So you can pull up the table. It's the bottom right button.
Yep, just pull up a
table and then set the increment and the distance, and you can get the SG, the whole flight of the bullet. So if you're curious will my twist rate work with blah 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 bullet, if it's in the library, you can easily check that and see what it does as it goes downrange.
And that library is constantly growing. We still have people sending in bullets. We're getting them added to the library. That's Hornady, Berger, Sierra, Vapor Trail, Nosler, Barnes. I mean, Arrowhead muzzleloader bullets. We've got a really 22 long rifle bullets. We've got a really good and growing stable of projectiles. So you don't have to guess for your long range bullets. You don't have to guess what the stability is now. All right, moving on now from that one to number 9. The jump equation rules until the group sizes get really small. Then reverse flow phenomena, gas expansion, and unburnt propellant grains, along with bullet design features, that's what dictates the dispersion. So the jump equation dictates dispersion until the groups get really small, and then there are other drivers.
Right. So back to the jump equation here. There's an aerodynamic term. Basically, this is lift coefficient derivative, one over the lift coefficient derivative. The transverse moment of inertia minus the polar moment of inertia, mass and diameter. Okay. So this guy here, if you were to suspend the bullet on a wire and use that as a spring and you displace it and let the bullet oscillate, okay? Think of it as a barbell being suspended from that spring, and you start with the masses way at the end of the barbell. And, just a mental experiment here, that thing would take an awfully long time to oscillate.
Mm-hmm.
You take those same weights, you haven't changed the weight of the barbell, you smash those two weights right close to where the wire is. Now that thing's going to oscillate much more quickly. Okay, so anything you can do to drive the transverse moment of inertia down, the better off you are.
Okay.
Okay, and as you stretch bullets and make them longer, that's got to go up. So that's part of that deal.
So the mass layout is one way that, as a bullet designer, you can manipulate that.
As long as they're not monolithic bullets.
Right. Well, then you're kind
when
of
they're
married
monolithic,
to what they are.
You get what you get. Yeah.
Yep.
Right. So back to the reverse flow, that can disturb the bullet just as the bullet leaves the tube. There is a parameter we use with bullets called jump sensitivity, and that's a number that's 0.007, 8, 9, whatever. And that's a metric by which we compare the bullet designs. How sensitive are you from a flight path deviation standpoint to a disturbance of the bullet as it leaves the tube?
And that's, just to clarify, that's not the same as jump in terms of seating depth.
That's correct. Yes.
Yeah.
Yes.
Or aerodynamic jump is it's kind of typically referred to as the effects of a crosswind. It's not that specifically, right?
Yes. And so you could see where, as you're in reverse flow here, you get a disturbance from either an asymmetric gas flow past the bullet or unburned powder whacking the bullet on the back end. That's going to disturb the bullet flight path.
We should show you before you leave today. But if we can drum them up, the high-speed footage we got, because you can actually see a supersonic gas flow there's a cone off the back of the bullet that, 4 to 7 inches out dissipates, and then you see the bullet get out of the gas flow and then start a supersonic supersonic flow the other way.
I think that last set of Schlerin, we caught some of that stuff, didn't we?
Yeah.
And so the other interesting part from a bullet selection perspective is the bullets with low jump sensitivity are less sensitive to inboard tilt, that sort of thing.
Mm-hmm.
But they're also less sensitive to the reverse flow.
Interesting. So goes to show, I think, the listener, one, that there's a lot going on, but two, hopefully that just this conversation alone about this talking point instills some confidence in the listener that Jayden, Miles, the rest of the team, with the help of Jeff and all the other engineers you guys have on the team, when you're designing bullets, like for the A-tip, for example, and any of our other newer bullet designs, this is not just, this is what we've always done, so we're always going to use this profile, we're always going to use this boat tail or this boat tail angle. That there is so much that goes into bullet design that nobody sees behind the curtain about this kind of stuff that you guys are looking at, testing, and in a small way being able to control to help it be more sensitive, or less sensitive, excuse me.
Yeah, I think because as a customer, you're looking price and BC for match bullets.
Yeah.
And we could make the BC really, really high if we wanted to.
Yeah.
But it doesn't.
And I mentioned the A-tip specifically because I feel like one of the biggest things we get back, and this just happened, and I'll tell that story shortly, but this happened when we first were sending out the A-tip bullets, where we sent them out to some of our acid checked. We know you're not going to put this on the interwebs yet. We're going to send you a bunch of bullets, shoot them, let us know what you think. And the resounding feedback was, it doesn't matter what propellant, doesn't matter what velocity, doesn't matter what jump depth. These things shoot better at all ranges than what I was shooting before. And a lot of it goes into this design. And just most recently, shooting sports manager at a big optics company, shout out to Nick if he ever listens to this, went 4 or 5 years shooting 108 grain ELD matches in the 6mm, shot some 110 A-tips for the finale, and I got an email from him, was like, all right, I'm hooked. I gotta have the 110 A-tips now. I can't not shoot those. And it was, people see that. They base it on price. They base it on BC. But there's way more that goes into it, and I think that's really cool and highlighted here.
That's interesting observation that it's insensitive to the propellants.
Mm-hmm.
Like, okay.
Yeah.
Not completely insensitive, but
less sensitive.
Less sensitive, sure. And notably different than what they were shooting before. And we've got some great products, and the A-tip is really just the pinnacle.
Yeah.
So there's,
one more thing on this. So one more connection point for the listener. This is what Jeff's talking about here is what you observe when you go cutting to shorter and shorter and shorter barrels and you see your group sizes open up. So the easiest example there is a 16 to 18 inch AR barrel versus a 10 to 11 inch.
Oh, like 5.56 barrel.
Yeah,
right.
Yeah, and generally what you're going to see is the shorter barrel is going to produce larger groups.
Mm-hmm.
Yeah. So that's the technical stuff.
Unfortunately for you.
Yeah.
Yeah, right. All right. So number 10, we've talked a lot about mean point of impact recently and group mean radius. And while that might not be the ultimate metric to really talk about dispersion with, it is the next progression to get away from just raw extreme spread on the group size. It's kind of the easiest to understand, and that's one of the reasons we went there first. This one says, the mean point of impact varies group to group based on the true dispersion and the square root of the number of shots fired, unavoidably. You might think it's the scope, ammunition, or parallax, but it's just your groups are too small.
So on the left-hand side here, we've got, again, simulation.
Mm-hmm.
Freely admit that it's a simulation. But, the little yellow dots, which are probably a little tough to see,
Mm-hmm.
are your 3-shot group mean points of impact.
Oh.
And the true dispersion here is equal to 100. And again, there's no units here. It's just, that's 100%. You can think of that as 100%.
Yeah, this is the total group is 100%
of your true dispersion. And so the little yellow dots that are scattered hither and yon are your mean points of impact for 3-shot groups. And, they're everywhere.
All over the place.
Yeah. And so I went and did 4-shot groups, 5-shot groups, 7-shot, 10-shot groups. And of course, right in the middle is the true mean point of impact. And, the idea with the big models is you can see, hopefully, without expending actual hardware, what's supposed to happen. And so it's pretty evident from that if you up the number of shots in the group when you zero, you're going to get something closer to the true main point of impact.
And I think the big takeaway is just looking at that, and you guys will discuss this, I think one of the biggest takeaways is if you're trying to hit something far away, you need to have a really good zero. If you're trying to hit it on the first shot, you need to have a good zero. And it's not a 3-shot zero. It's not a 5-shot zero, not a 7.
And I've noticed a stark contrast to, I guess, my shooting in precision PRS and NRL and just general long-range shooting from before I stumbled into the large sample size stuff to after stumbling into that and now shooting 20-shot zeros. Like, get my muzzle velocity from 20 shots, zero from 20 shot, set
and
the
running a zero angle.
Yeah, running zero angle with a 20-shot group, mean point of impact. My zero shifted today has not happened. It just doesn't happen anymore unless like I destroy the barrel on a barricade or something, unless you do something way out of whack that your scope internally stops tracking or you bend the barrel or shift the barrel in the receiver. Like, unless you do something way out of line, the day-to-day mean point of impact zero shift just stops happening once you put enough into the initial test.
Yep. This graph too is sensitive to the overall dispersion itself. So if you had a system that shot every single bullet in the same hole, you would only need a 1-shot zero for that to be representative of the total shot distribution. So the worse your gun shoots, the more rounds you need to zero with. I mean, we've kind of settled on 20 for the precision rifle, kind of at least do this much, because most precision rifles are going to fall below a certain threshold, right? You're not going to take a 2-minute precision rifle load ammo combination to a match, right? So generally at 20, you've reduced the variability to the point where to your point, Miles,
you're well within a click of the scope. So
and you don't see varying zeros, But the other thing that can happen here is don't shortchange yourself. Do the 20-shot zero, have a very stable one, but then go to a match, and the day before the match is, you can check your zero and register and do all that stuff, and go lay down and shoot 3 shots and be like, oh, my zero shifted. Because again, your 3 is going to bounce all over the place.
We see it every time, and you've talked about the cost associated with that.
Yeah,
it's wild, but you do see it every single time that you go to a match.
Quite a few years ago, I had a friend that had a 22 that he was pretty proud of, and it shot pretty well. And he burned up a whole box of ammo zeroing the thing. And by the time he got done, he had a hole chewed in the paper that was probably 1 inch in diameter, and he probably didn't have a really good handle on the zero, but he knew where it was.
I can tell you where it is,
and
within a certain amount of error.
Yeah, and that might work for your application. Yeah. But if you're in the business of hitting stuff far away, presumably on the first shot, you can't afford to just run 3 5-shot zeros or something like that. 3 to even 10 shots, and then call it zero range 100. It's good, because it's going to wander. And this is actually related. I just got back from a hunt where we spent a ton of time talking about this topic, where there's been some other guests on another podcast that have talked about a certain brand of scope having zero retention problems. It just doesn't hold zero. It's like nobody's ever presented data to support it other than just anecdotal. Oh, the scope didn't hold zero. Well, define hold zero, because if you shoot a 3-shot group and then a week later shoot another 3-shot group, it's a guarantee
it's going to be different.
That it's not going to be in the same spot.
Yeah. You've got like a better than 50-50 chance that it's going to be over a click one direction or another off of where it was the last time.
And then depending on the dispersion of the rifle, it could be considerably more than a click. I thought that was pretty topical.
Yeah, so the graph on the right-hand side shows you as a percent of the true dispersion of the system, what fraction of the mean points of impact are within a certain miss radius. So I just picked 50%. And if you're shooting 3-shot groups, you've only got 33%, 32% that are going to be within half of the dispersion of the system. You take that up to 15 shots, now 80% are going to be within there.
Okay.
So it's like, this is on my website.
Yep. That's fantastic. And yeah, it really, we should just rename the podcast "Your Groups Are Too Small."
The HIT Target Impact Indicator. Instant hit confirmation at extended ranges has never been easier. The HIT Target Impact Indicator easily attaches to most target stands and not the steel target itself. The highly sensitive internal accelerometer detects vibration when the target is impacted, activating the red LED lights that flash Morse code for HIT. Where impact confirmation can be difficult, light it up with the HIT Target Impact Indicator from Hornady.
Moving on to number 11. True dispersion, aka group size, varies from group to group, and there's not much you can do about it. You can reduce your anxiety about it by using the average sigma x and sigma y, or using mean radius instead of the easy and widely variable extreme spread. That right there, that's an uncomfortable truth. I don't want to hear about it. I'm just going to continue using extreme spread.
Okay, you can be wrong. It's fine.
Yeah, it's okay to be wrong sometimes. All right, so you're saying dispersion varies from group to group, and there's nothing that you can do about it unless you shoot all of the shots. And
then you've got no ammo left.
Then you've got no ammo or no barrel left to do it, right?
Yeah.
So dispersion varies from group to group. The best thing you can do is lower your anxiety about it by getting a better handle and a better means of measuring.
Absolutely.
Okay.
Absolutely.
Let's dissect this one.
Or a time machine.
Good point.
Yeah, so on the left here, I have a plot of the average dispersion versus group size and the targeting metric. On the top there is the average extreme spread, and you can see as the number of shots go up, as you go to the right here, that metric does nothing but climb.
Yep.
That's the average. It's not the variability. The variability's over here, and that does decrease a little bit with increasing number of shots, but not as much as you'd like it
and not at the rate that you would like it to.
Absolutely. And again, this is the dispersion variability is a percent of the true dispersion. So the mean radius and the average of the sigma x, sigma y, that's pretty flat.
Stable.
It's pretty flat.
Yeah. And I would say questionably flat. I mean, that looks like there is essentially no change after 10 shots.
Again, average. This is the average over a pile of shots. And here, this is the variability. So obviously, the more shots you shoot, the less the variation is going to be from group to group to group.
Yep.
And I think, like, in terms of putting it in the context of what most people do for load development, where it traditionally had done a ladder test or an OCW test to change a variable, shoot a group, and then compare those to say definitively, this is better than this is better than that. If you really break it down to the level of confidence that people would like, you're looking at like probably several hundred shots of each variable to get to the level of resolution that people think that they can measure it to or should be able to measure to. It's an astronomical amount of ammunition you'd have to expend to really truly test that to ground and be confident, 100% confident in it.
Yep. And I took essentially the graph that Jeff has on the right here. I took, because that's all simulated. That's based on simulated dispersion, right?
So you did the real numbers.
I did.
And we're going to drop this in over the top so that the viewer can see your
so what
Microsoft Paint skills.
Book to follow.
Yeah.
What I did is I took 11 series of 100 shots. So these are real. We did this. We shot these. Okay. So there's 11 different data sets, and it kind of spanned the dispersion spectrum, right? There was some of these data sets where they were like incredibly good, like 100 shots that were, right at a minute of angle or a touch under at 200 yards, to stuff that was 2 to 3 minutes for 100 shots and everything in between, right? So you're kind of getting a sampling of different dispersion profiles that you had talked about, Miles, within this data set. So what I did is I said, okay, we have 100 shots to work with, and with those 100 shots, we can figure out what the group size is and what the mean radius is and the radial standard deviation or the sigma SDX of X and Y. at 100 shots. We can get all those metrics. So what happens if we go back to the first 3 shots and we calculate those metrics? How do those two reflect each other?
Ooh.
What's the group size at 3 shots versus the group size at 100? And I did that across all of these 11 data sets for each of those metrics.
That's a ton of shooting.
Yep. I did them at 3 shot, 5 shot, 10 shot, 20 shot, 30 shot, and 50 shot groups. So at those sampling rates, how do they reflect what actually happened at 100? What's the errors between 100 and those? And what you see is with group size, and this is the average error across all 11 data sets, right? With a 3-shot group, the average error at a 3-shot group compared to what happened when there was 100 was 66%. That's a lot.
Real confidence inspiring.
So just to make an easy example, let's say that the dispersion result you got at 3 shots was 1 minute of angle.
Okay.
That means it could stay that good out to 100 shots, or it could be 1.7. And that's the average error. So there's going to be errors that are worse than that in there.
Sure.
But the main point of this is to compare the different dispersion metrics. So group size is almost double, right?
Yeah.
You could have a lot of error. You really don't know what you have at 3 shots with group size. When you go to radial standard deviation or standard deviation of each shot radius, at a 3-shot group, it drops down to 35% average error. So it's twice as good of a metric as group size.
Okay.
Mean radius is 36%. It's twice as good as group size as a metric. Average of SDX, SDY is 40%. It's nearly twice as good. And as you go down, when you do a 5-shot group size on average is going to be off by 50%. All those other ones is 27, 32, 28. You go to 10-shotters, group size is off by 30. The others are off by 20, 28, 22. 20 shots, group size is off by 18. The other ones are 20, 18, 13. So the graph that we'll show on the screen pretty much shows that group size is always the worst option, getting better between 10 and 20 shots. But the interesting thing to note will be to look at the number of shots of 30 and look at how all of those start to converge.
Right.
So another way to look at this graph is, one, there's really no good way to cheat sample size. You can cheat it with a dispersion based metric based on a standard deviation or a mean radius, and that will help you much better than group size. But there's no replacement for sample. You cannot get away with it. If you want high confidence, to Miles's point, in knowing what this thing's going to do into the future, you have to have a high sample size. It's the only way to do it.
You can't shortchange it.
If you do, you have a lack of confidence. It's that you're trading off confidence,
and you're going to pay for it.
You will.
And you're probably in the process going to have a 0 that you think wanders on you. So this just compounds. Probably going to be late on your rent that month too. I mean, it's just everything is stacked against you when you start doing the small sample size stuff. That was really neat though, Jayden, that your just the shape of the graphs really
track pretty closely.
That's a 10,000 shot simulation. That's a huge sample. And then you've got 1,100 shots legitimately fired and tracked, and to put the proof is in the pudding there. That math doesn't lie.
The trends are the same.
Yeah, and I think too, I had initially thought that you had done the same math. I don't think you guys did exactly the same math with these. So
no, I tried to simplify it as
I was trying to argue with him before the podcast
at predicting what actually happened.
Yeah,
yeah. What's remarkable to me when you start looking at extreme spread was it gets better the more shots you shoot, but it wasn't until like 20 where it was close.
Yeah, and it's the same thing. You see, and it doesn't matter what you sample, really. Like if it's got a normal distribution, which like the X and the Y generally have a normal distribution, it doesn't matter whether it's shooting or people voting or whatever you sample. Like by the time you get to 35, 50, you're pretty much there, and that's kind of like your best bang for your buck.
Minimum threshold.
Right.
Sure. Yeah.
What's 10 shots was still what, 50%? 30%.
30%.
So
the average error in groups, so the difference between a 30-shot group size and the 100-shot group size of that same stuff, the average difference between those two was 30.
Yeah. To me, that 30%. Is incredible because that's in standard form. That's a huge sample size. Most people are still shooting the 3-shot, 5-shot group. So you double that and go to 10. it's still a huge number of variability.
Mm-hmm.
So that just continues to drive home your groups are too small. And there's no way to short circuit it. There's just no way. The only thing you can do is face reality, lower your anxiety by getting a real picture of what your system's capable of.
And I mean, and I don't know, I've had people argue with me too that like, okay, well, this is just purely the rifle. Like, what about the shooter? It's like, well, yeah.
What about the shooter?
Factor that in. What about,
that might be the biggest factor.
Right.
Yeah, right.
Going from prone with the bipod to, off a barricade to standing or whatever. Include all of that. Shoot a group where you put 10 rounds in each position and see what that looks like, because that's your real world dispersion pattern, right? Like that. You're not cheating that, right? You go out just because you did it here and it's not what you like. When you go out and you got a trophy animal, that's not going to perform. Yeah, it's not going to perform any differently.
Not going to get better.
That was awesome, guys. That was, of all the things we've talked about, they've all been good, but this is one of those more uncomfortable truths, those uncomfortable ballistic realities that I think we're really seeing a decent trend of people kind of realigning. Now, are we going to get everybody? No, of course not. But I feel like, and maybe we're in an echo chamber, but I feel like the years that we've been talking about this stuff with your guys' help, with Jeff's help, we're seeing more and more shooters really open their eyes. And, we've got some help on the outside too. There's some notable people in the industry media space. Got Tyler Friel at Outdoor Life, got Pap Winkle, Colton Bagnoli out there that have went, I don't know, I'm going to test it for myself. They tested it for themselves, saw the light, and now their outdoor media, whether that's videos, Instagram, actual articles published, it's reflecting this larger sample size mentality, and that's really helpful.
Yeah. I know. Because when I first started posting this on various forums and stuff, I just got flamed immediately in the beginning, and now it's
all a big plot.
Yeah.
To shoot more ammo.
Yeah, Hornady wants to sell more bullets.
This only applies for Hornady bullets. You shoot somebody else's brand bullet, the 3-shot groups are fine.
The Hornady Security Fireproof Keypad Safe. With a heavy-duty 16-gauge steel body, extra thick 8-gauge steel door, and 4 1-inch diameter locking lugs, the fireproof safe achieves a fire rating of 30 minutes for up to 1,400 degrees Fahrenheit. Both the interior and adjustable shelf are covered in a protective carpet that offers flexible storage configurations while safeguarding valuables from damage. The Fireproof Keypad Safe from Hornady Security.
All right, moving on to our last and final point here. Number 12. There are 2 parts to the long-range targeting error budget: the random effects and the bias effects. The random effects can be reduced by load tuning, and the biased effects are reduced with skill and experience. Yep,
you like that?
Behind the bull.
You like that? Mm-hmm. Yeah, so this is a little graphic that shows you the target and your groups if you don't correct things. Mm-hmm. Okay. So the bias errors, the components of those add up in a vectoral sense. So if you have a wind bias, that blows the whole group off the target. Okay. If you have a velocity bias, the velocity of what you're firing is different than what you measured when you did load development. That's going to push the group higher or lower than what you sighted in with, perhaps. Okay. And the interesting part here, to me anyway, is the fact that almost all of the factors have a bias component and a random component, or a potential random component. So like angular rate, it's entirely possible for you to have a non-zero angular rate. And I'm talking plus minus in terms of the wobble direction and magnitude. Okay, left, right, same deal. It's possible for that to be non-zero, that average to be non-zero. Barrel's crooked. Bullet runs around the corner, and it goes up, down, left, right, and the average is not zero. So it's but you zero that when you zero the firearm. Okay, and it's the variability in the angular rate that causes a chunk of this dispersion, the scatter of this fall of shot about the displaced mean point of impact.
Interesting.
There's wind components. There's scope cant components.
Aiming variability.
Yeah. All of the components. So the drag variability, velocity variability, the cant we talked about, the angular rate, cross velocity. There's portions to each. The skill part comes in, can I read the wind? That's if you had to pick the biggest one, isn't that the biggest one you'd pick?
Yeah. Only because rangefinders are so available now. I mean, 30 years ago, it would have been
15 years ago, 10 years ago.
Possible.
Yeah. And the lack of rangefinders back in the day was what drove the high velocity craze. That's why Weatherby got where they got. They're pushing that to solve that problem.
That's right.
Yep. Yeah, with rangefinders, you said 30. It doesn't have to be that long ago.
Yeah.
We've all talked about the rangefinder where I went to 250, so you had to drive the truck 250 yards away, put a flag in the ground, then drive the truck another 250 yards away, and that was 500 because it would only go to 250. Okay. So that wasn't that long ago. I mean, it's getting longer, but that really wasn't that long ago.
Yeah.
Those days are, and there's many, many other things that the shooter can influence. Just manipulating the trigger. That's something that I feel like gets maybe not the focus that it deserves. Is your breathing, your natural point of aim, and the trigger manipulation.
Yeah, fundamentals of marksmanship. You can't cheat that either.
No, they're fundamental for a reason.
Yeah, it's you would be better off to learn how to shoot than to buy every shooting accessory that there is.
Yeah.
Yeah. Yep. I feel like with a really dialed in system, you can take a very novice shooter. Jayden did this just a few weeks ago for a hunt. Guy had never shot past 200 yards. Jayden had him on a factory rifle shooting factory ammo, ring and steel at 1,000 yards. No problem. I don't think he missed on his way to 1,000. It was like, wow, that was easy. And we talked about this. I think it was on the podcast. A really nice dialed in long range precision rifle is easy to take a novice and get them to do that. You reduce the range and reduce the size of the firearm. You can find a expert rifle shooter winning competitions that can't shoot couldn't hit the ocean if they were standing on the beach with a pistol. But you find a pistol shooter that can stack bullets, they're almost always going to be to transfer those skills into a precision rifle.
Right. Yeah.
That's because the manipulation inputs are...
You were forced to nail the fundamentals with a handgun.
Yep.
Yeah.
And I think the fundamentals, as far as the shooter goes in this context, can often be overlooked, but are equally as important.
Yeah. And I know, like in our world, like the PRS world, a lot of people poke fun at it, and we do as well. It's like if all you ever do is put a 25-pound rifle on a sandbag and it's going nowhere, and you just point and shoot, and it has no recoil because it's the tiniest little caliber ever, that's not going to necessarily increase your shooting ability, to the level that you might think it would. Whereas if you get out and you shoot a 30-06 offhand and get to where you can master that, offhand shooting the positional stuff, like the old NRA kind of stuff.
Yep.
High power, whatever, positional stuff. Then you take that skill and put it into PRS, and you're a monster.
Yeah. Or I think the NRL Hunter does a good job of blending those. Now you're not really shooting unsupported, but you are shooting significantly lighter rifles that have more recoil than the standard PRS rig, and you're shooting from positions that aren't just what we lovingly refer to as barricade bench rest.
Right.
Yeah,
it's not something you can practice ahead of time, where a lot of like the PRS is not standardized in all of the things you're going to run into, but there's some commonalities.
Yeah, it's a certain height of a stable barricade. You put a bag on it, you put a rifle on it.
If it's a tire, if it's a wood box, you shoot off them the same if they're the same height.
Yeah.
But when you're out in the environment and it's, hey, you have to shoot from here, we don't care how you do it, but there's your targets, that's a different ball.
Right. And I think in the hunting world, you get a lot of guys that will shoot off a bench or shoot prone when they're at the range, and that's all they ever do. And rifles, sight the rifle in, rifle zero, good, okay. I'm shooting a good group, I'm ready. And then you go out and it's off a tree branch or a standing shot or something. I mean, or, whatever it ends up being, it's a different thing if you don't practice for it. If you're not ready for that, then that's where a lot of failure happens.
That's when you kill an elk and you find somebody else's bullet in his rear end.
Yeah, exactly. Yep. Well,
I hate it when that happens.
Yeah.
Well, killing the elk's been pretty cool. That was neat.
Yeah.
Jeff, do you have anything else in this world or for this podcast about just anything else that we didn't cover in your list?
I have nothing else at the moment. I'm sure once I get
back on the road, something else will pop to mind. I hope it does, because I love doing these podcasts. I know our listeners enjoy the technical stuff, and if they don't, at least they'll be able to enjoy your very festive shirt.
Well, that's what I was going to say. There's one more important thing Jeff needs to cover, especially for the listener that's not watching, and that is what is Jeff wearing right now?
My NASA ugly Christmas sweater.
That lights up. I noticed that
lights up.
We got all the lights on in here or whatever, but earlier when we first walked in the room and it was dark, it's more festive than you think.
Yep. Yeah. Excellent. I love it. I don't think it's an ugly sweater at all. Matter of fact, it's quite seasonal. Looks great. Guys, is there anything that you want to let the listener know about this podcast and some of these uncomfortable realities and truths?
There's an element of me that wishes I could go back to when I didn't know these things, because from a dopamine standpoint, it was way more fun. Like thinking, man, I'm going to change this thing and this is going to be great. I'm going to test it. And it's either like dopamine high or just crash, right? It's either great or it's not.
Binary.
And now it's like kind of humdrum, like, well, guess I'll load
your dopamine
20 of these, and it met my threshold.
It's harder to get that dopamine fix.
Your dopamine trends with the variability of
group size.
That's right.
Group. All right.
On average, you're good though.
But the average is pretty even keel. Awesome. Well, gentlemen, I appreciate you coming on the podcast. I appreciate you geeking out on all the technical stuff that most of which went over my head, but I'm sure our listener, the advanced hobbyist, the non-Bubba, I think that they're really going to enjoy this one, and hopefully we can get you around the table to do some more in the near future.
Sounds good.
Thanks.
All right. Ladies and gentlemen, thank you for tuning in to this episode about some uncomfortable and possibly mind-altering ballistic realities. We really appreciate Jeff coming on. We love having him as a guest. If you haven't, you need to check out his book, Ammunition Demystified, the Non-Bubba's Guide to How Ammo Really Works. Thanks for tuning in. We'll catch you on the next one.